Hello and welcome to my presentation about domain-driven design and how to apply them in the API world. Okay, this is part of the Apidays London 2023 session, and I will avoid talking about the technical aspect, but rather I will try to sell you the concept. It's something interesting and something that shouldn't cost you and your company any really significant money. It's just a mindset. And what is interesting is it is actually a realistic approach to the way you manage, you organize the APIs that has been around in the business world for a very long time. But quite strangely, not many people have thought about applying the DDD concept to the APIs management. And as you would see through this presentation, it's quite straightforward. It makes sense, and it's not, as I said, it's not costly. So hopefully it will motivate you into investigating further and investing in this idea a little bit of time, and it will give you a lot of benefits. Some of these benefits, one is high reusability. We're talking really like a very good reusability ratio. Second is a lot easier understanding of what each API is doing and what is not doing. And that should give you faster access to market or faster reaction to the market. So from a business point of view, there are a lot of benefit in organizing the APIs using the domain-driven design concepts and the other concepts that go around it as well. Okay, so let's get going. So the first thing that I'd like to put forward is, from a development point of view, it is the understanding, not the knowledge, that becomes software. Alberto Brandolini is quite a famous name. He's the father of event storming, and I think you should read a little bit about what he did. But this particular sentence is quite interesting. Knowledge can be acquired, but if you understand the business reason behind it, we understand the solution, the overall solution, or what you call the end-to-end solution, understand the integration aspects of it, understand the need for APIs. As a developer, that will be reflected in your code. But if you go for the engage, disengage mantra, where you put, somebody puts the files in front of the developer and tells them, this is what I need from you, then that, whatever they understood from that particular situation is what they're going to convert into software. That was not very agreeable way of doing things back in the SOA and the monolithics, and certainly doesn't fit nowadays style. Focus on the understanding, on the other hand, is quite beneficial, and we're going to explore that as well. So Eric Evans is the one who coined the word or the domain-driven design concept as a concept. However, the concept itself existed way before this, particularly in the business world, and you're going to see that in the next slides. So when do we do, or how can you think about the domain-driven design? So this is a simplistic way of presenting how business needs evolve in terms of structure in the business, but obviously it varies from a company to another. So let's say you have a corporate strategy, okay? Some of these strategies would be, what business should be in? Are we going to sell shoes? Are we going to sell water? What are we going to do? And what are we not going to do? So if you say we're going to sell shoes, but we're not going to make boxes for this shoe. So you define what is the high-level strategy of that corporate. From there, you define the business strategy. What is that supposed to mean? What are the goals of the company? How are you going to fight and compete in the market? So there are different aspects how you strategize for your business to reflect the corporate strategy. From there, so you have a business strategy that is clear now. You develop a model around it. How do you do this? You start describing the core aspects of the values, from economical point of view, from a social, environmental, etc. And also you reflect the purpose of the company. So you can model your business. We're gonna get shoes from here, the soles from here. We're gonna sell in this market. So you have a business model that is clear and understandable, and everything reflects the boxes behind. So essentially, this is an FYI, but more than anything, there is an upstream production and downstream consumption model, which is a linear model. A good example is you have the pan, you have the lid, you put the lid in the pan, you sell the whole thing to a wholesale company. That's a linear process. but you also have a network, which is basically you can borrow, you can buy from those to whom you sell, and so on and so forth. Okay. Now, you have developed the business model. Okay. You start splitting it into domains or activities or functions, depends on how you look at them. I mean, a good example is you would like to focus on the human resources separately from your production mechanisms, okay? So these are different domains, and you would hire different people for different domains. So I'm not describing something new here. I'm describing how businesses usually operate. You have an accounting, people who are busy with accounting. You have the customer service, and then in the production itself, if you're producing a car, you have a team that works on tires, teams that work on the bodies, on the engine, and you would want them to have some sort of autonomy in the way they are managed, the way they are managing the data, the way they are producing things. There is a relationship, but it is a relationship. They shouldn't be mixed up. So that's how you define your business domains, and that's where the domain-driven design came about. When you develop a solution, an IT solution, or a business solution, but it's been going on for a while, the business solution that is, you would want to focus on the domain where you operate in. So if it's a tire making team, you want to develop a solution, an IT solution for them that doesn't have dependency on the accountant, okay? So that allows you to focus on the project that you have in hand and on delivering the business needs and requirements specific to that team. And that makes it a lot easier. But there are other benefits as well from thinking about domain-driven design that we will go through very soon. So the idea is to structure the code, to structure the solution, structure the design by domains. Right. The right side of what I showed, which I go back very quickly, the right side of this is what constitutes the realm of domain-driven design. As an architect or as a designer, you don't worry too much about the corporate strategy, business strategy. They have all reached the point where they have a business domain that is well described in different domains and different characteristics of these domains. So this is effectively the corner where we deal with them, with the business, with the domain-driven design. Now, the normal question is, when do we use DDD? We use it when the business logic is complex. This is very important. If the business logic is not complex, for example, it's a small company, you have one software that does everything, okay? Few people, etc. It's very hard to find a place where you can divide those, those functionalities within the same application, within the same company into different ones. But if the business logic is complex, for example, corporates, insurance company, banks, multinational companies and whatnot, but these are the higher case. Even local companies with a complex business logic, they can definitely profit from the domain-driven design. If you have a complex technical environment, but the business logic is complex, DDD is useless. So it's not about the complexity of the technology or the solution, it's about the complexity of the business. That is very important because the DDD reflects the business into the APIs. That's a key sentence that we're going to prove in the next few slides. So what are the main principles that drive domain-driven design? 4 of them. You have YAGNI. You ain't going to need it. YAGNI is quite important. To be honest, I would say it's important in IT projects in general. The idea is, if you don't need it now, don't deliver it now. So I'm not going to deliver, say, a piece of code, an application that we might need in a year time. If you know we need it in a year time, then it's not YAGNI anymore. You develop and you deliver for the needs. But yeah, we work on say the tires. Let's produce bicycle tires. We might sell them. No, okay. So the idea here is to keep it simple. Okay, it's a KISS concept. And that allows to a short development time. So because you only develop small bits at the time, and that allows the maintainability of the code. This is quite important because there is a principle called code for the maintainer or something in that sense. What that means is effectively there is somebody who's going to maintain your code. They're going to look at it in a year's time. They're going to try to understand it. Make sure they would understand it. So your code has to be simple, has to be nicely documented, not heavily documented, and has to be clear, structured, and organized, so that the next person who's going to enhance it or reuse it, they know what to do. So very quickly here, I'll go back on the YAGNI concept. So it's a true pattern. I apply it in almost everywhere, okay? And the idea is to deliver what is needed and exactly what is needed. Now you have to be careful. YAGNI is not about technical debts, okay? It's technical debts. I have my own beef with it. You know, I think it's a terrible thing, and I know many organizations and many projects, they use it as actually a tool, but all it does, in my opinion, is effectively it offloads the problem to somebody else, and then you have that registry of technical debts and whatnot that keeps piling up, and nobody's going to look at it at the end because it's become so complex, and these technical debts become interdependent that you cannot resolve them in the future. So YAGNI doesn't say that. YAGNI says if you need it, do it. If you don't do it. Simple. Skimping is what we call a quick and dirty. This is, I mean, of the two, this is worse than the technical debt, because what that means is usually the project would deliver what you need very quickly, very cheaply, by cutting corners, by using, you know, by mixing two APIs in one, by having, you know, shared resources when you don't have them to be shared. I mean, a simple example is, let's say, you know, an insurance company, you know, search policy and search claims for the same customers. They shouldn't be amalgamated in search API. It's quick, it's cheaper, but then when you go later on for the enhancement and for the management, it becomes too complex, too costly. Years ago, those who have gray hairs like myself would know that with the SOA, it used to take about 5 years to pay for the lousy and lazy approach to coding. Nowadays, with the APIs, with the IIoT, big data, and whatnot, the return on investment or the return on the cheekiness is a lot shorter. You'll be lucky if you survive over a year before your code is problematic. And I've seen situations where people effectively, the release of release one of the overall solution, they haven't gone live with it yet, but they know it doesn't work with the release 2. That's because of skimping and technical debts. So YAGNI is not any of these two, but it's something that you certainly have to keep in mind. Now, as I said, DDD reflects the fact that projects in complex business contexts cannot be modeled in a simple way. You can say, yeah, there is a single service that does everything. Well, I mean, in reality, you can, but you are creating a monolithic that will soon become problematic. So DDD tells you you have to reflect how the business is structured and organized, okay? And also, just to be clear, most companies, they don't sell IT. They sell wood, they sell shoes, they sell, you know, building material, whatever. So the solution that the IT people provide have to be fit for purpose to the business needs. DDD allows that because the IT solution works in the realm of the business. And I'll show you some example later on. All right. Very quick comments here. Enterprise architecture is easier to implement because your solutions and your code reflects the business. The EA's purpose is to reflect the IT strategy, which reflects the business strategy. So eventually, by applying DDD, you make the EA more reflective on your IT landscape. So DDD is bi-directional between the developers and the domain expert. This sentence here, I will elaborate on it towards the end because this is key thing in implementing DDD. All right. Now, if you go online and you start to read about DDD, you will find two things: the strategic design modeling tools and the technical design. Think about the first one is how you organize, how you develop solutions, you create solutions, how you provide, you know, architectural designs. The second one is effectively how to implement these things. So because this presentation is about selling DDD to you, trying to explain to you why DDD is very good, beneficial for your company and for your API management, I'm going to skip the second one, but there's a lot of documentations online. I'll probably touch on it very lightly, but overall, it's something that is worth pursuing once you have decided DDD is indeed a good thing for you. Okay, right. So this is the example that I use, which is building a boat. The most common example you find online is a house, and I will show you what to do with this, what it is about. Why I prefer the boat, because the dependence of the domains on a boat are a lot more tighter than in a house. I'll explain later a bit more details. So your friend wants a boat, okay? It's a mid-sized one. I call it yacht here. That's a mistake. For leisure, so it's not for business. It's not like renting it. Sorry, and it's for family during summer. Yeah, okay. So it doesn't have to be winter-proof, and it's only a few people because it's only summer, only a family. Now, what do they need in the business? They need a stable boat. They need capability to eat hot food, drink cold drinks, and have fun. Okay, the captain, because the captain is not going to be one of the family members, so we probably need to have them sitting in front. Okay, that's something that we need to know. Okay, now we understand what is needed from the business point of view to build this boat. When you want to draw that on the boat, you just do circles or squares like this, and you start naming them. This is where the kitchen is. This is the logistic. So far, what I'm been presenting to you is nothing magical. It makes sense. You know, that's how the business is split. That's how the boat is split. We refer to these as domains. Now, for the jargon, proper jargon, the context map is basically the overall map of the domains. You draw them together, then you see which domain is closer to which domain and eventually how they're going to interact between them. Okay? The core domain is the central important domain that around which all domains orbit, and it changes from one industry to another. I will not put a lot of stress on it because it's probably a detailed level. But the key thing is you're going to have your domains operating independently, but with some sort of a relationship between them, or fencing or bridging. Okay, so this is the example of the house. You have a garage, you have a kitchen, and the idea here is if you want to change the door of the garage, you shouldn't be worried about the living room. They are two different domains, so you should be able to, you know, basically enhance things. I mean, add more to domains. You want to reduce something from domains, or you're gonna create new domains, or even destroy domains without real impact on the other. Granted, there is a dependency between these domains. They share the land, they share the ground, the infrastructure. They probably share a wall between them. You can destroy it, but that's as much as it can be in terms of dependency. Within the garage inside, if you want to change the fuse on the power, you shouldn't be worried because this is going to affect on the I don't know, on the say plumbery, you know, in the shower or something like this. So this is a common sense things. They're basic things. You do them in life, you do them in business. Now you can do them with the APIs. All right. So a little bit of jargons here just to explain them. The bounded context is what limits the domain. Okay, the domain has a context. You know, it's a human resources domain. That's the context. So it's bounded by the HR rules and whatnot. Okay, all together they form the context map, and each you know, domain has its own model. So you will start modeling and designing for each domain separately. Now, the ubiquitous language is very important. We have to speak the same language. So this is very important. If it's called sleeping compartment, it should be called like this, or gathering place, sorry. So if I call the gathering place meeting place, you know, you are forgiven to think it's a different place. It's something else, another domain. So the language has to be the same. Usually it's the business language that is replicated into the IT team. But sometimes it has its challenges. A good example is client versus customer. You know, some software use client, some software use customer. and the business would be using both. So these are exceptions, but you in general try to speak the business language when you are presenting solution for that particular domain. The anti-corruption layer is the one layer that protects the whole design for that domain from systems of records. So think about it. You have an ERP system, you have a you have a CRM system. They have different document types, have different ways of security, of mechanism of connectivity, response, and whatnot. Some event-driven, some APIs. It's all over the place. So you don't want that complexity to creep into your domain APIs or the APIs and the bounded context of that domain. So what you do is you have a layer of anti-corruption that deals with that. It converts everything from and to the system of records to a standardized, or you can call it canonical, or domain-specific contracts and data models and whatnot. Okay, that allows you to thrive inside the domain. We're going to show this with some pictures very soon. But let me give you an example here, so you can understand how this works. The customer is one object. It's a person. It's you. It's me. We know that customer exists physically. However, for the policy domain in insurance, so the policy domain would be about making policies, basically selling policies. For them, the customer is about the active policies, the historical policies, midterm adjustments. These are the important basically pieces of data or datums that are related to the customer object. The policy domain doesn't care about the customer's phone number. So the people working in the policy domain, they don't want to know about that, and they shouldn't hold that data, because you're holding other domains hostage. You go to the claim team, they're dealing with people who had the unfortunate accident, and they're trying to recoup some losses. So what they do here, from their point of view, the customer is about claims open, historical claims, no claim discount status, and whatnot. They don't care if they do have an MTA historical policy or not. So for the same object, the two domains hold different details, even though it's customer, party, or person, or people, or customers, or whatever you call it. That domain is interested in your social details, your name, your physical address, Facebook page, I don't know, the mobile number. But they don't want to know if you have active policies or not. That's irrelevant to them. And then you have a domain of contentious, the lawyers there. They will be interested in other things. You have the, as I said, the HR, it's different. And then you have the underwriters, it's different. So different domains, they can focus on that object from their own point of view. They don't care about the rest. Now, so event storming, effectively how you implement the DDD is basically bringing everyone that you need, but only those that you need. So it's both, not too many, not too few. And then you start developing, having like a cyclic or repetitive, iterative approach to the solutions, okay? And then this is where the tactical, remember I talked about the strategic versus tactical tools. This is a tactical aspect of it. So I'm gonna just put it there very quickly. And this is how, for example, for Java, instead of using the int as a Java primitive, use the domain primitive, like claim number, and then you use that in your code. It gets a little bit more interesting if you go with more details, but we're going to skip this for now. Now, let me show you how this has been implemented in the case of insurance, because I gave the example of insurance, and we're gonna really understand it much better now with the real case. Okay. So first of all, this insurance company, it's a global insurance company, doesn't have well-defined set of domains from a business point of view. They operate in the domain realm, but they don't explicitly separate them and name them. So all we had to do is we had to look at obviously there's experience there. We had to look at these basically functions and these departments and come up with the domains for it. We understood very well that with time, some of these domains would probably be wrong, or would be corrected or increased or reduced or split based on the business defining its domain finally. But mostly we would get it right. Policy domain is policy domain, claims domain, etc., etc. So we went for the full cloud, 3-tiered architecture. Now, you can implement DDD in different ways. So don't think this is actually the way to do it. But in this case, this was the way to do it. And we had 3 layers. What we call the domain gatekeeping layer. This is not the gateway. It's a gatekeeping layer, whereby the access is managed. Every domain has an access. Your living room has a door. Your garage has a door. You can have 2, but you have doors. These are where you allow things and people to get in and to get out. Then you have the abstract layer in the middle where the business logic is done. This is the meaty stuff, the juicy stuff. You know, you do orchestration, you do choreographies, you model for the business, enrichment, and whatnot. So this is, you do whatever you want, whatever you're doing today, you keep doing it within that domain, obviously, tomorrow. Then you have the anti-corruption layer, as I said to you. This is the layer by which you go to get data from systems of records without having to hurt the abstract layer and the DGL, the main gatekeeping layer. Now, I talked about the domain, the core domain. In insurance, usually it's the underwriting, okay? But in this case, we went for the policy domain. I'll spare you the reason why. But basically, one thing to note is different business focuses are not domains. Okay, so car insurance and motor insurance, property insurance, these are not domains, these are business focuses, but the domains are below: policy, claims, you know, etc. Right. As I said, domains can be split if they become too big, and you need to split a couple of them. What you need to know is effectively no API should belong to no asset. Every API belongs to a domain. Every API and every asset, every application belongs to a domain, and only one domain. If one API belongs to 2 domains, you are cross-contaminated, and we're going to show you the example. It's quite interesting. So this is very important. If search policy belongs to the policy domain, it is for the policy domain. In the claims, you will have search claims for the claims domain. This is a high-level explanation of how you can separate them. So the search policy belongs to that domain, but it doesn't belong to the claims domain. A common thing in when you come to domain-driven is you have like the shared utility miscellaneous domains where you can virtually put any domain. I compare this to that last box in a form where they say, do you have anything else to add? So it's a free text. You can write whatever you want, but somebody has to interpret that. So we might get the wrong data from there. We don't want that. We want you to select A, B, or C, then we know what to do with the data. Similarly, we want each API to belong to clear domain. We shouldn't have those vague domains, okay? Some domains are not business domains. Right? Like you can have one for purely technical, but if you have more than 3 APIs on that domain, it's a rule of thumb, you're doing something wrong. Okay. All right, now we're talking about the cross-contamination, all right? So each domain would treat the other domains as strangers, just like systems of record. So the policy domain doesn't trust the claims domain. I have my own APIs, you have your own APIs. We need a formal way to exchange data, but you can't just basically create a dependency on my search policy directly. You can't call it directly. And I'm going to show you how you do this, okay? Right. So here is an example of the claims versus policy. You have the 3-tiered or 3-layered architecture I talked about, the gatekeeping, the abstract, and the ACL API layers. So consumer A, somebody from the claims team goes in, asks for for some information about the claims. Hang on, we need to get data about the policy. So let me call the abstract layer API in policy domain to get that data. This one here is a cross-contamination. You probably are doing this today if you're not doing the DDD. Every API is open to consumption. It's internal to the company, isn't it? Well, that actually effectively, or you call straight the system API, or sorry, the anti-corruption layer, you effectively are extending your claims domain. And those 2 APIs, they become belonging to 2 domains. So if tomorrow the policy team decide to update their search policy API, they have to liaise with the claims team because they have a straight dependency on it. You can't just, change it. You can't. So because the claims team have to update the API. Welcome to the nightmare. So the DDD's job is to make sure that this doesn't happen. How do you do it, may you ask? Very simple. Every request to a domain from outside the domain has to go through the domain gatekeeping layer. So the claims, like if it's a third party stranger, has to go through the control access, the door, and then you go down and you get the data you want, okay? So acting as a gatekeeper, you can enforce security about your domain. You have full control because the APIs are below the layer. They're not accessible directly from the outside, okay? Same thing, I mean, with all of them. That improves the reusability as well, because if the policy team wants to change how they search for policies, the claims team doesn't care. Their contract, the API contract, is with the gatekeeping layer. That doesn't change. The contract between the gatekeeping layer, and the abstract API, that is part of the policy domain, and it belongs to policy team. And they can organize that, they can sort it out internally. So any changes inside the policy domain, the other domains are oblivious to it. That reduces the regression testing, the dependency, the cost of enhancement and modifications, and that increases your access to market. So you react very quickly to the market. If you need something to offer something new in terms of policies, you can do it quickly. You don't have to worry about it as consumers, okay? Usually we have one API per gatekeeping layer, per domain. Usually it's RESTful, but you can have a couple if you want to also have a SOAP and whatnot. There are ways to do it to make it efficient, but usually you can number how many APIs you need because you look at how many domains you have, and probably few domains of them, they have also SOAP requirements or anything of different style. Now, if you noticed, we talked about domain gatekeeping API. We're not talking about specific consumer. We don't say this API, this experience API, or this gatekeeping API but is to deal with the London market, okay, with Coca-Cola, with Pepsi, with no. That is actually one of the common mistakes in the way people structure their APIs, because you will end up duplicating your APIs for the same partner because they have different needs, but also the same need from different partners. So this structure reduces the number of APIs and increases the reusability very, very, very remarkably. Right, so in this case here, we use channel-based. So, you know, if you're RESTful, you're gonna have an API, a gatekeeping API, you go through it. If you're SOAP-based, you're gonna have another API. How many channels do you really have usually? One, and then SOAP, you know, probably two, okay, at max, okay? So this is very good because we know how many APIs we need. And I did mention there is a technical domain where you can apply, you know, some strategic logic that is purely technical, but this cannot be a common thing. Now, these are not miscellaneous domains. It's very important to understand these are technical needs. So it's not like email API. I'm going to put it in miscellaneous. Where would you put the email API? In the communication domain. Document creation, where would you put it? In the documents domain. So these are domains that are taken care of, that specific aspect. Communication, we have Twitter, Facebook, emails. If you need to communicate with anyone, go to that domain and tell them what you want. So the comms team, or you know, would be focusing on that, not caring about who's consuming it, the dependency of who's consuming it. They go through the gate, okay? And as I said, you can predict the numbers. That's very important. So the gatekeeping APIs have to be lightweight. They don't usually get versioned. So every consumer will have their own endpoint, and they will be forwarded to the lower layers or the other APIs directly. There is some basic validation and transformation and proxy and whatnot, but effectively you don't have to version. And if you don't version, that means you don't do regression testing. Existing customers, existing consumers, they don't know, they don't care about it, okay? If you start having heavy load working on those APIs, or I even like load outside some basic validation transformation, then you're going to create a dependency on that API, and suddenly, if you want to change it every time you have a new consumer, you have to check with with other usability API. That's key thing, to keep it very lightweight, extremely lightweight, almost proxy-like. Okay, very good. Now, this is a good example because it has some repercussions in terms of physical location of data. So you have a system of record that has both policy data and claims data. Okay, so physically it's the same system, or it's just same database, you know. And when I say physically, I mean application layer, let's say, you know, as a system of record, it's the same system of record. Now, the policy team come and say, okay, I mean, you know, since there is an API to that system of record, I'm going to use it to get my policy data. What you're doing here effectively is you have one ACL API that is working for claims and policy. That is cross-contamination. So for the same system of record, each domain would have its own ACL API. You would treat those two parts of that domain as if they are separate domains, separate systems. And every time you want some claims data from that domain, from that system, apologies, then you call the claims ACL API. There is nothing in the policy ACL API about claims. If tomorrow you want to export, you want to get rid of the claims data on that system because it was done there by laziness or by mistake or like historic data, then all you have to care about is the claims domain and its ACL API. The policy domain continued to work very nicely. And what this means is to apply, to implement DDD on your API, you don't need to separate data physically between domains. It's something that you should aim for, but it's not a sine qua non condition. It's not like you must do it. In the same, if I take an example of a SQL database, a basic database, you know, an Excel sheet, row 1, 2, 5, and 20 belong to the policy team and belong to the policy domain. Row 2, 4, 16, and 30 belong to the claim domain. The claims know, the APIs know they can only search in these rows if you want. Same with the policy domain. Ideally, you would separate them, because if you remember the customer box, everyone has its own database, but it's not sine qua non. You can get on with your DDD, and we did that. So we don't have to rush the company into modernizing everything. No, when they modernize, it's very easy. That anti-corruption layer, it has to be replaced with the new one pointing to the new claims system, okay? So if you need policy, effectively, you go through the policy domain, as I said, through the Gatekeeping API, and then you get your data. Now, so hopefully I explained to you how you structure your APIs based on the business domain. You are not reinventing the wheel. The business has structured its way like this, explicitly or not. So you reflect that by putting each domain's API separately, and you make sure they go through the doors to communicate and get each other's information. Now, this is a soft aspect of it. The developer is very important in these things, because they will be, if it's a agile, they would be, you know, working with the train. That was the case here. So there's a policy train, and you will have developers working for that train. So them understanding what that domain does and does not, and how it functions, make sure that they can make quick decision. Okay, you can't call on the architects for everything. They are empowered. So it's not engage, disengage. Here it is. They are engaged from the beginning. They are part of the solution. They understand why, and then in the meeting and the stand-ups, they are quite quick to highlight what could be done better and what not. So this is what we call the reverse pyramid. In terms of documentation, I mean, I'm a big fan of Agile Manifesto, so it's a very minimum documentation. What we did is one HTML document per project that has two parts: high level, that where the architect has to fill up his details or her details, and then low level, where the developers, the engineers working on the case that put the contracts, the samples, and every technical aspect. So this is the ownership, and the whole document is owned by the delivery, the team or head of delivery, who would have to check that before the APIs can be released into production. Okay, so what that does effectively, it empowers the engineers. They are the ones who develop the rammer. We review them. They peer review them, and we review them on on specific situations. So they are autonomous, they're quite agile, they're quite strong. It's a fair assumption to say that out of 100 developers, you get at least 90 of them wanting to do good. So if they fail delivering properly, this is the reverse pyramid I was talking about. That means we didn't give them the right tool or the right support or the right information. Usually with DDD, your developers, they are micro or mini architects as well, and it works a treat. So there's a lot of benefits. They grow in the role as well. You do maintain them. It's a big problem to maintain developers nowadays. There's a huge demand for them, particularly with known technologies. So this is a good way for them to feel empowered and to thrive. And later on, they move to architecture work. Okay, all right. So these are some of the good reasons, if you want. The enterprise integration patterns is probably, I like it because I'm mostly in the integration realm. But the other two as well are quite interesting. If you have any question or comment, or if you need any help, the door is always open. There's my LinkedIn. Hopefully you like this session, and I'll see you when I see you. Cheers.